So coordinate systems are the way that we find ourselves on the surface of the Earth. All the GIS data that we have has some sort of X and Y value, such as we see here, of where these individual points are. So this point would be this far in the X direction, this far in the Y direction. And for a gridded data, each one of these XY locations would be represented by a different grid cell. But the important thing in both cases is that these XY locations know where they are on the surface of the Earth so that they can that we can use it in addition to other data if we're layering things together. So we say that these types of maps are geo-referenced. You can make your own coordinate system if you wanted to. If you were drawing a map of a building or some buildings on a campus or someplace, you could just pick an arbitrary 0, 0 and see how far all the edges of the buildings were in the X direction from that 0, and how far all the edges of the buildings were in the Y direction from that 0. And then you could get a coordinate for any point within this area here. This would be something like an arbitrary coordinate system. In GIS, we typically don't use these. We use standard coordinate systems that people are familiar with and the GIS software is able to properly display. Some examples of the standard coordinate system. This is a USGS topo sheet that's showing a school called Doty's School here. And we can talk about its location in a number of ways and actually measure this from the edge of the USGS quadrangle sheets, which have these markings along them. The top one here would be longitude and latitude. And we can see the first number here is the longitude in degrees, minutes, and seconds. And this is the latitude in degrees, minutes, and seconds. But we can also have X and Y coordinates. The second one here is UTM, or Universal Transverse Mercator coordinates for the same point. We're just representing that in a different way. And we can also, in this case, have state plane coordinate systems for the same point. So these aren't unique. It all depends on the coordinate system you're in. But once you know what coordinate system you're in, then you can uniquely identify any location on the surface of the Earth. So in general, there are two general categories of coordinate systems. One is called Geographic Coordinate Systems, or GCS, and sometimes we say this is unprojected data. This is based on a sphere because a sphere does a pretty good job of representing the Earth. And in this, we can measure the coordinates in two different ways. The lines of latitude would be these east-west lines running across here. And the lines of longitude would be the north-south lines running across here. And we can see that this really isn't a distance because these distances can actually change depending on where we are on the sphere or on the surface of the Earth. This is actually an angular measurement that we make in order to determine what latitude and longitude we're in. And we can see the longitude can vary from 0 all the way around to 180 or minus 180. So there's 360 different degrees of longitude. And for latitude, it varies from 0 here to plus 90 at the North Pole, minus 90 at the South Pole. But a lot of times we use projected data in GIS. And projected data has somehow taken the data that we have on the surface of the Earth and has put it onto a flat piece of paper. In this example here, we can see we've shown a light from the center of the Earth through the Earth here and onto this curved piece of paper like half of a cylinder. And it's left a print of where those different lines of latitude and longitude are. If we then took that piece of paper and just flattened it out, we would see lines of latitude and longitude that look like this. This would be an example of a projected coordinate system. The way that we actually do this in GIS is, of course, not with a light, but with mathematical equations. And the reason we do this is to project information from a 3D world, a 3D Earth, onto a two-dimensional map, whether that's a piece of paper or a flat computer screen. Once we have these coordinates, these are stored with the GIS data in the Geodatabase. So in some case, we might have, for example, these states where we're storing the projected coordinates in the Geodatabase. In other cases, for example, like with the roads here, we can see that these coordinates are still latitude or longitude and latitude numbers. So we can store information on the coordinate system in either way, either projected or unprojected, in the Geodatabase.